taking your radicals for square roots. This is our lovely little square root symbol. And guys, the number inside of your radical is called your radicand. All right? So your radicand is that number inside the radical. So in this case, it was n. And guys, what we are going to be trying to do is we are going to be trying to find factors of that radicand that are perfect squares. So what I would like you to do is we are going to fill out this lovely little perfect squares chart here to remind ourselves what are the perfect squares. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. And so on. So please fill out the rest of your lovely little perfect square chart here. If you guys, hopefully these lower numbers, you will pretty much know off the top of your head. If you need a calculator as the numbers get a little bit bigger, that is okay. There's no shame in that. So if you need a calculator as you keep going, that is okay. I know most of my perfect squares up to 20, but off the top of my head. But guys, once you get past 20, it's a little bit harder for me. I would recommend having numbers 1 through 15, these 1 through 15 perfect squares, in your brain somewhere. All right? So lock it in there and have that stored in your brain. So we are going to be going back to these today. Really, honestly, most of the ones that we're going to be looking at are under 10 or 10 and under. But it is good to know these off the top of your head. All right? I also have these written up on the board so that we don't always have to flip back. And guys, I have made this lovely little foldable for you. So if you guys would like to now flip to our lovely second page here, we are going to be talking just about simplifying radicals. Okay? So guys, our big rules is we want no perfect squares, factors, inside of your radical, okay? We also want no fractions inside of our radical. So we are going to separate, if we have a fraction, we're going to separate it into 2 things. And we want no radicals in the denominator of a fraction. That is not going to be an issue today. We are going to cover what to do with that and how to rationalize that more next class period, okay? So, for now, guys, this is just a lovely little hint. Anytime you see something with a radical, please put the radical or the square root in the calculator first. Always, always, always put the square root or put the radical in your calculator first. Because, guys, if you are given something like, I don't know, the square root of, let's go with 289. And guys, it spits out a nice, pretty number for you. You are done. That's it. You're done. If you are given the square root of a fraction, you still put that in the calculator first. Because guys, if it spits out a nice, pretty fraction, you're done. You don't have to do anything else, okay, guys? So if it spits out a nice, pretty number, or if it spits out a nice, pretty fraction, you are done. So always, always, always put it in the calculator first. And then even when it doesn't work, it will still be beneficial. So for example, I'm going to do number 1 right here, the square root of 12. Did that spit out a nice, pretty number? No, 3.4641, 1615. That is going to be an irrational number. That is not a pretty number. So that tells you that we are going to try to simplify this guy. Okay? So how you simplify it is then what you want to do is you want to find the largest perfect square factor. All right? And so if you don't know how to do that off the top of your head, that's where you go to your y equals and you do that number or the radicand divided by x. So hopefully we know the factors of 12, but even if we don't, we can sit here and we can do 12 divided by x, and then you go to your table, second graph. Yikes, I'm all the way up on 28, so I'm going to go back to 0 or 1. And guys, when I'm looking at these, I want to find the largest perfect square factor that is inside of 12. So y'all, oops, that was wrong. So y'all, is 12, and the reason why you want the largest one, we'll talk about it in a second. But guys, is 12 a perfect square factor? No. What about 6? What about 4? Yes, it is. And my two factors are 3 and 4, or 4 and 3. So what I'm going to do is I'm going to go over here, and I personally like to write my perfect square first. You don't have to. That's just my preference, okay? But if you, I just always put my perfect square first, even if it's the smaller number or the bigger number, okay? And so then I look at this and I say, okay, I can write 12 as the square root of 4 times 3. Well, guys, what 4 is my perfect square? What is the square root of 4? 2. So this becomes 2 square root of 3. Do y'all feel good about that? 2 square root of 3. So here we go. When we do this, 2 square root of 3, remember guys that really nasty looking number we had? I'm going to go type in 2 square root of 3, and I really hope, would you look at that? They are the exact same nasty looking number. Do y'all feel good about that? So guys, as we're doing this, you can simplify it, and you can get 2 square root of 3. Now guys, one of the most common mistakes that I see when we are simplifying radicals is that students will forget to take the square root of that 4. And they'll just write 4 square root of 3. They'll just yank it out of the radical without taking the square root. That is super wrong, okay? That's a very common mistake that students make, is they forget to take the square root of the 4, okay? But that is not correct. All right, y'all? Now, I'm going to show you guys how to do one with a coefficient, and then I want you guys to do 2, 3, 4, 5, 7, 8, and 9. Kind of practice that on your own, okay? So what we're going to do is we're going to do one with a coefficient. So guys, when you have one with a coefficient, you do almost everything the exact same, but I'm going to go ahead and I'm going to do my little rule here. I'm going to do 3 square root of 28. Let's see if it gives me a nice even number. It absolutely does not, but we know that's what we're going to be searching for. So now, guys, I'm going to simplify radical 28. So I'm going to go here to my y equals, do 28 divided by x, and I want to find the largest perfect square that goes into 28. It could be in the y column. It could be in the x column. In this case, it's in our x column. So, guys, the largest perfect square looks like it's going to be 4. Do y'all feel good about that? So the largest perfect square is going to be 4. So I'm going to write that as 4 times 7. Once again, I don't care which one is bigger. I just care, I write the first one as my perfect square. All right, guys? And now the square root of 4 is 2. So this becomes 3 times 2. And then, unfortunately, the square root of 7 got left inside of that radical. We don't take that out. So 3 times 2 is going to give us 6 radical 7. Okay? But how do I know if I am correct or not? Ooh, gosh. So I'm going to go here and I'm going to write 6 radical 7. And would you look at that? I get the exact same weird, nasty looking decimal. Do you guys feel good about that? Awesome. Okay? And so what I want you guys to do right now is I want you guys to work on numbers 2, 3, 4, 5, 7, 8, and 9. I want you guys to try. And the reason why I'm having you do all these on your own is because we have actually done these before, if you do recall. So I want you guys to work on simplifying. All right, so I want to go over a couple of these with you guys. So for the square root of 18 here, we can break that down into 9 times 2. And then the square root of 9 will give us that 3 Square root of 2. Are you guys good with that? Y'all feel good about the 3 square root of 2 there? I guess I can do that in my little pink. All right. Now, guys, the square root of 27. What is the largest perfect square we can break number 3 into, y'all? 9 times 3. We got that 9 again. So the square root of 9 is going to be 3. And so that becomes 3, square root of 3. All right, guys, that's that 3 square root of 3. Once again, one of the most common mistakes that I see with these is people will just take out the 9 and make it 9 square root of 3. I don't know if you can really see that with a, there you go. It'll just say 9 square root of 3. That is wrong. Do not do that. You have to take the square root of 9 before you can take it out of the radical. Okay. Now, guys, I was not doing my little rule here where I said, okay, check it. Because if I check the square root of 27, I see it's this 5 point, yada, 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 long little thing. 3 square root of 3 gives me the exact same weird-looking decimal. Guys, I highly recommend typing them in at the beginning because look what happens when you type in the square root of 36. What does it give you? 6. Guys, the square root of 36 is a perfect square. So that means your answer is just 6. But Miss Humanek, what happened to the radical? Well, there's nothing left inside the radical, so you don't have to leave it. You don't have to put anything there. So guys, the answer is just 6. The most common mistake that I see students trying to do on problems like these are like the easy peasy ones that students will mess up because they'll write like square root of 6 or they'll write like 6 square root of 6 or something. They're like, no, there needs to be a square root. No, there doesn't. If it gives you a nice clean answer, you're done. Okay, so it just stays as the square root of 6. Do y'all feel good about that? Awesome. Now we're going to look at the square root of 10. So guys, this one is interesting. Okay, when we type in the square root of 10, does it give us a nice clean answer? It does not. It gives us 3.16227766, right? It does not give us a nice clean answer. Okay, but guys, does 10 have any factors that are perfect squares? 10 only has 1 and 10 and 2 and 5. Neither of those are perfect squares. None of those factors are perfect squares. So guys, this one is actually already simplified. So guys, it already gives you the answer. That one is already simplified because there are no perfect square factors. If there are no perfect square factors, then you are already simplified. Okay? Some of my most annoying already simplified ones. 10, square root of 10 is already simplified. But 10, because it's an even number, it just feels like you should simplify it more. I don't know if anyone else feels that way. Like you're like, no, I can do something else with it. Another one that's really common is the square root of 6. I guess I'll write this here. That one is also already simplified. But it feels like you could do something more to it. And honestly, the most annoying one, in my opinion, that is already simplified is square root of 30. Because there's so many factors to 30. 1, 30, 2, 15, 3, 10, 5, 6. But none of them are perfect squares. So guys, these are all good examples of ones that are already simplified, but they feel like you can do more, but you can't. Most of your other even numbers like 8, 12, 18, 24, 28, 32, all those guys, you can simplify those, but these you can't, and it just feels like you should, all right? Any questions for me on those guys right there? Nope. Awesome. All right, let's take a look at number 6 here. All right, so I want someone to help me out with this. Andrea, how did you simplify number 7 here? Sorry. Number 7, how do we simplify number 7? Oh, either, Andrea. Rock, paper, scissors. All right, Rincon, you're up.
Okay. for 48, we do 16 times 3.
16 times 3. 16 is the largest perfect square factor for 48. Excellent job. All right. And then what is the square root of 16? 4. So that becomes 6 times 4. And then our little 3 was left inside of the radical. So it's times the square root of 3. So that becomes 24 square root of 3. Are you guys good with that? Did anyone do this guy a little bit differently? Did anyone else find a perfect square that goes into 48? Are there any other perfect squares that go into 48? Well, 12 and 12 don't, but 12 and 4, right? Okay, so hold on, guys. I want to show you an alternate method here that that kind of highlights a point for me. All right? So 6 times square root of 48, you could have also written it as 12 times 4, or 4 times 12, right? And the perfect square of 4 is 2. So that becomes 6 times 2 times the square root of 12. Is that where you got the 12 there, Asya? So then that becomes 12 square root of 12. All right, guys, so go with me on this. Hang tight. I want to show you guys a very common mistake that students make, okay? Because if we go here and we type 6 times the square root of 48, ladies, if we type in 6 times the square root of 48, we get this really long-looking nasty decimal. And if we type in 24 square root of 3, we get the exact same long-looking nasty decimal. But if I type in 12 square root of 12, what do you know? I get the exact same long-looking nasty decimal. But guys, there's only one right answer. So this is actually not fully correct. What else can I do to this square root of 12, y'all? Yeah, you can break it down into 4 times 3. And guys, what's the square root of 4? 2. So this becomes 12 times the square root of 2 times the square root of 3. So that gives us 24 square root of 3. So guys, if you don't pick the largest perfect square, that's 16, you will still get the answer, but it just takes you a lot more trips to get there. Does that make sense, guys? Does anybody have any questions for me about why we want to pick the largest perfect square? All right, so what I want you guys to do, let's look at 8 and 9 real quick. All right, so here is numbers 8 and 9, okay? 2 square root of 200 gives you 20 square root of 2 because the square root of 100 is 10. So 2 times 10 gave you 20, 20 square root of 2. Negative 3 times 32, negative 3 times the square root of 16 times 2. So negative 3 times 4 gave us negative 12, negative 12 square root of 2. Do you guys feel good about that? Yes, no, maybe so? Awesome. All right. Yes, what's up?
I'm still writing.
Oh, you're still writing. Oh, okay. So we have numbers 9 and numbers 10 right there. By that, I mean numbers 8 and numbers 9. I'll get there.
Okay.
Numbers are my strength, I promise. Okay? Here we go. Okay, guys, what happens to number 10? If you type in number 10 on your calculator, what's going to happen? It gives you an error. What is the error that it gives you? Non-real answers. So guys, it gives you an error and it says you have non-real answers. So y'all, your error, that is because you cannot take the square root of a negative. Okay? So you cannot take the square root of a negative number. It will give you imaginary numbers, okay? So actually, the correct answer to this is 10i, all right? And so, but we are not going to do imaginary numbers in Algebra 1. So there is an answer. It's just not a real answer, all right? It is for all of your imaginary friends to play with. All right, guys, y'all feel good about that? All right. And don't forget, that's why it's so beneficial to type these guys in your calculator. So if we get to number 11, did anyone type, let's go and do this guy, the square root of 49 divided by 36. What is this going to give us, y'all? A pretty fraction of 7/6. But let's talk about why. It is a pretty fraction of 7/6 because, guys, you can rewrite, when you have a fraction inside of a radical, you can rewrite it as two separate radicals. And, guys, what is the square root of 49? And what is the square root of 36? So your final answer is 7/6. Do you guys feel good about that? Awesome. Okay, for number 12. So that's why I recommend type it in your calculator, because it could give you this nice, pretty answer. Let's try it with the next one. I got sad news. This one's not going to be pretty. It's going to be a really tiny little decimal there. Square root of 5/81. So I'm going to rewrite that as the square root of 5 over the square root of 81. And guys, can I simplify the square root of 5? No, there are no perfect squares that go into the square root of 5, so that stays as it is. Can I simplify the square root of 81? What is the square root of 81? 9. If you need a refresher, you can flip back to your front page and look at that. The square root of 81 is 9. So the square root of 81 is that 9 right there. So guys, this would be our final answer because it is worth checking yourself. I'm going to go here and type in the square root, not like that, the square root of 5/9. And would you look at that? I get the exact same weird, nasty looking decimal. All right. So number 13, we are going to look at this and we say, man, can this one be taken the square root of 18/25? Ugh, no. Gives you a nasty looking decimal. So now I'm going to separate it out into the square root of 18 over the square root of 25. All right? So let's take a look at this. Can I simplify the square root of 18 at all? Does 18 have any perfect square factors in it, you guys? Oh, 9 and 2. Look at that. So we can do this into 9 and 2. So that would become, now guys, can 25 be simplified? Absolutely. It can be simplified into 5. Well, guys, the square root of 9 is 3. And our little 2 got left inside the radical. And it was over a 5. So our final answer was 3 radical 2 divided by 5. I want to double check myself. So I'm going to go here and I'm going to type in 3 radical 2 and I'm going to divide that by 5. And we get the exact same weird, nasty looking decimal. Do y'all feel good about that? Awesome. Any questions for me on how to simplify radicals? Do y'all feel good with this? Okay. So guys, we're going to take it to a next level here. All right? We're going to take it to the next level. I want you guys to turn to the multiplying radicals page. All right? Now guys, when you are multiplying radicals, what you got to do is you got to multiply them and then you simplify. But Miss Humanek, what do I multiply? Well guys, you multiply the outside by the outside and you multiply the inside by the inside. And then once you've done your multiplication, so first you multiply the outside by the outside and the inside by the inside. Once you've done your multiplication, that is when you go ahead and you simplify. So guys, these are the rules that we are going to do. You multiply your outside by your outside and your inside by your inside. All right? So for number 1 here on this page, 5 times 30, are they both inside the radical? Yeah. So we're going to do 5 times 30. Now guys, I'm not going to lie. I usually don't write this step, but I want you guys to see what's going on in my brain, okay? So I do that 5 times 30, and that gives me the square root of 150. Now, can I simplify the square root of 150? Let us see. Oh, you know what? I forgot my rule here, didn't I? I forgot to type this in. So I'm going to type in the square root of 5 times the square root of 30, because I want to make sure it's not nice and pretty. Nope, it's not. But now we know what we're trying to get when we get our answer here. So I'm going to go here, and I'm going to do 150 divided by x, and we're going to see how to simplify 150. Guys, what is the largest perfect square that goes into 150? 25. 25 and 6. So I'm going to rewrite that guy as 25 times 6. Now, guys, what is the square root of 25?
5.
That's going to be 5. So my final answer is 5 square root of 6. How do I know if I'm correct? Let's go ahead and check this out. 5, not square root of 5, 5 square root of 6. Do I get the exact same weird, nasty looking decimal? I absolutely do. All right, do you guys feel good about that? So guys, really, when you are multiplying your radicals, it's not that different. You're just multiplying the outside by the outside and the inside by the inside. I'm going to look at number 4 here. All right, guys? For number 4, the outside by the outside. Weird. Well, guys, that's really kind of like a 1 square root of 3. Are you guys okay with that? So we are going to say that's really kind of like we're saying 2 times 1 times the square root of 15 times 3. Once again, y'all, I don't usually write this step down. I do that in my head, but I wanted you guys to see what was going on in my head. So that becomes 2 times the square root of 45. Interesting, okay? So I'm going to go here. I forgot to do it at the beginning like I'm supposed to, so I'll do it now. So that's 2 times the square root of 15 times the square root of 3. Gives me this weird, nasty looking decimal. Okay, 2 square root of 45. Can we simplify that square root of 45, y'all?
Yeah.
How can we simplify it? 5 and 9, yes. So that becomes 2 times the square root of 5 times 9. I usually write my 9 first, but it's not a big deal. So I'm going to take the square root of that 9. And what is the square root of 9, y'all? So that becomes 2 times 3. And then our little square root of 5 got left, our 5 got left inside that radical. So guys, what is 2 times square, or 2 times 3? So that is 6 square root of 5. Because 2 times 3 is 6. Let me make sure that actually makes sense. 6 square root of 5. Would you look at that? I get the exact same nasty looking decimal. Okay, guys? So I did numbers 1 and 4 for you guys. I would like you guys now to do numbers 2, 3, 5, and 6. All right? 2, 3, 5, and 6. All right, guys. So for numbers 2, 3, 5, and 6, this is what I got here. All right? Now, once again, I usually don't write this 14 times 2 step down, but I wanted you guys to know what was in my head. So, guys, that was the square root of 28. But now we got to simplify the square root of 28 into 2 square root of 7, okay? Because that became 4 times 7, and the square root of 4 is 2, okay? 21 times square root of 3, that becomes square root of 63, which we can break down into 9 and 7. The square root of 9 is 3, so that becomes 3 square root of 7. Are you guys good with that so far? All right, for number 5, 4 times 2 becomes 8. 2 times 6 becomes 12. So guys, if you stopped at this part, you would still get partial credit, but that is not fully simplified because you can actually simplify the square root of 12 or radical 12. So we simplify radical 12 into 4 times 3, and we get 8 times 2 times the square root of 3. So we got 16 square root of 3. All right? Once again, one of the most common mistakes I see right here is we just take out the 4. And I see people make that 32 times the square root of 3. Because they're like, oh, 4 times 8, great, 32. That is wrong, all right, guys? That is wrong, but that is a very, very common mistake among students and adults alike, all right, guys? When you're going too fast, sometimes you forget to take that square root, all right? For number 6, I kind of broke it down for you guys. 5 times 3 gave us that 15. 8 times 6 gave us the 48. Then we can simplify the square root of 48 into 4 square root of 3, and 15 times 4 was 60 square root of 3. Any questions for me on those guys right there? Do y'all feel good about that? Awesome. Okay, so next we are going to take a look at what happens when you distribute. All right, so on here, guys, one of the things here, we have our number on the outside. What I want everybody to do really quick is I want everyone to practice typing this into your calculator, okay? So even if you're like, no, I'm great at it, well, just please practice because, guys, 2 square root of 2, you have to use the little arrow key to get out of your square root there. Or if you're on like a TI-83 plus, you got to use the parentheses. And then you do this guy here. So that would be, 3 square root of 20. And then you got to get out of it. And you got to hit plus 5. So guys, please practice typing that in so you can make sure you don't type in the wrong stuff there. All right, and you should get 52.089. If you don't get that exact same decimal, that means you did something wrong. All right, do y'all feel good about that? You feel good about typing that in? Okay, so we want to make sure we have the format correctly. All right, then guys, I'm going to think about this in terms of distribution. So guys, we have 2 square root of 2 times 3 square root of 20. And then we are going to do 2 plus 2 square root of 2 times 5. Are you guys good with that? We're taking our 2 square root of 2 and we are distributing it to both terms inside of there. And now we treat these like they're separate little problems. So we go here and we say, okay, well, we're going to do the outside by the outside. So 2 times 3 is 6. And 2 times 20 is 40. So we have 6 square root of 40. Are y'all good with that? Then we're going to do the outside by the outside. So that's 2 times 5. So that's plus 10. And then the inside by the inside. Well, guys, do we only have one radical? Yeah, we just got square root of 2. So we're going to do square root of 2 times nothing. So it's just square root of 2. Do y'all feel good about that? So that is how we simplify our lovely little radicals. Are we done? No. The square root of 40 can be simplified. So now we are going to simplify this guy just like we did the other one. So this becomes 6 square root of, what is a perfect square that goes into 40, y'all? 9 does not. Let's look at this. If we have 40 divided by x, what is a perfect square? 40 is not, 20 is not, 10, 8 is not. What does it have to be? 10 and 4, doesn't it? 4 and 10. 10 and 4, 4 and 10. So I'm going to do 4 times 10. And guys, what is the perfect square of 4? 2. So now we have 6 times 2 times the square root of 10, which is really just going to be 12 square root of 10. Are y'all good with that? Then, can we simplify 10 square root of 2 at all? Nope. So that just becomes plus 10 square root of 2. And y'all, check this out. That is our simplified version here. Because you cannot combine radicals unless the radicand is exactly the same. And is square root of 10 the same thing as square root of 2? No. So you cannot combine them. So that becomes 12 square root of 10 plus 10 square root of 2, which gives you the exact same nasty looking decimal. Do y'all feel good about that? Awesome. All right, so then for number 9, I want us to do the same thing. I'm going to do number 9 down here. So guys, we do the square root of 6 times 7 square root of 3 plus the square root of 6 times 6. Are you guys okay with that? So y'all, for our first little term here, we're going to do the outside by the outside. Well, guys, is there anything on the outside of that one? So it's 1 times 7, so that just gives us 7. And then the square root of 6 times the square root of 3 gives me the square root of 18. And then, oh, well, I guess we have this whole number, 6 plus 6. Times this lovely radical, which is square root of 6. It's not square root of 36, it's 6 square root of 6. All right, guys, does that make sense? You got to do the outside by the outside and the inside by the inside. Okay? Now, are we fully done? Is this guy simplified right here? It is not, unfortunately. So, guys, we can rewrite this one as 7 times the square root of 9 times 2. Are you guys comfortable with that? Okay, the square root of 9 is 3. So this becomes 7 times 3. And then our little 2 got left inside of our radical. So it's times the square root of 2. 7 times 3 is 21. 21 square root of 2. And then, y'all, we can't simplify 6 square root of 6, so I'm just going to add 6 square root of 6. And we are done. Does that make sense, you guys? Y'all feel good about that? All right, I want you guys to try to do numbers 8 and 10 fully on your own. Do numbers 8 and 10 fully on your own here. So, y'all, for numbers 8 and 10, we had the square root of 5 times 5, which gave us 5 square root of 5. And the square root of 5 times the square root of 5 gives us the square root of 25. Well, guys, you can't simplify 5 square root of 5, so that just comes down. But you can simplify the square root of 25 into negative, minus the square root of 25 is minus 5. Now, guys, fun facts about this right here. Anytime you multiply a number, a radical by itself, like if I did radical 8 by radical 8, do you know what that's going to give me? Square root of 64, which is 8. Isn't that super cool? All right. Now, guys, for little numbers like 5 and 8, that's not a big deal. Like square root of 3 times square root of 3, you're like, cool, that's the square root of 9. Well, the square root of 9 is 3. So, guys, if you multiply a radical by itself, it spits out what's inside the radical, which is pretty cool. Okay? That comes in really good handy when you have like these giant numbers that are kind of annoying, like the square root of 17 times the square root of 17. For you just to know that's equal to 17 saves you, because guys, honestly, I don't think very many of you are going to be like, oh yeah, the square root of 17 times 17 is the square root of 289 off the top of your head. So it saves you a little bit of math. So guys, when you multiply a radical by itself, it spits out the number that was inside the radical. It's pretty cool, right? So that's a good little lesson there. Also, when we look at this, 2 square root of 3 times 6 square root of 2, that gives us 12 square root of 6. 2 square root of 3 times 4 square root of 3 gives us 8 square root of 9. Or we can also rewrite that as 8 times 3, which gives us 12 square root of 6 plus 24. Any questions for me on numbers 8 and numbers 10? Or do y'all feel pretty good about that? Awesome. All right. So, guys, that is a good review on how to simplify radicals and how to multiply those lovely